Hello, my name is Hir Patel, and I attended the lecture about gravitational waves and how we hope to observe them. This lecture was led by Professor Cadenati and Shoemaker. I chose to attend this particular lecture because space is something that I've always been interested in. The universe is filled with so many unknowns, and I know that science is always getting one step closer to finding the many answers. Professor Shoemaker began the lecture by discussing the theory of relativity. Specifically, she discussed how gravitational fields have only a relative existence. For example, when a person is free falling in a gravitational field, it is as if the gravitational field does not exist. If a rocket is accelerating upwards, the gravitational fields at the top and bottom of the rocket are different. Because of this, a clock ticks slower at the bottom of the rocket. If you treat your heart as a clock, this means that a person closer to the bottom of the rocket is actually younger. I found this particularly interesting. Einstein's theory of relativity also relates to black holes. Black holes have a large gravitational pull that would require you to travel faster than the speed of light to escape. If someone was to jump feet first into a black hole, the gravitational pull at your feet would be so much stronger than the gravitational pull at your head that you would stretch out. This is called spaghettification. Black holes are formed from massive stars at supernova. Our sun is much too small to form a black hole. Suns and black holes both form gravity waves. Professor Cadenati then took over the lecture and began discussing gravity waves. Something I found particularly interesting is that black holes make a specific sound when they form. Gravity waves are very important because it is a new way to explore and learn about the universe. They can help answer questions such as, how do stars explode? How many stellar mass black holes are there in the universe? Another interesting fact about gravity waves is that they are strains. Knowing this makes it possible to detect them. In America, we have the Laser Interferometer Gravitational Wave Observatory. It's called LIGO. The United States now has 2 LIGO locations, and many other groups around the world are also helping to detect and learn more about gravity waves. This lecture made me want to learn more about the efforts being made in order to detect gravity waves and uncover the unknowns of the universe. An article I came across discussed another method for observing gravity waves. This method involves watching a population of stars close to where 2 black holes are merging. If the most massive star gets brighter first, and the next most massive star follows, this is usually a sign for the presence of gravity waves. The universe is changing and evolving every day. The study of black holes and gravity waves is a key to understanding these changes.